Forthish. A small embedded forth is simple to build using most popular programming languages. Here, we will look at such a simple implementation in Python. This is not a full implementation of forth. This is simple.py. As it stands, it contains fewer than 60 lines of Python code and can only invoke built-in routines. A later version of the code will show how to compile and save compact forth words. In forth, a function is called a word. Simple.py runs a little REPL, a read eval print loop. It prompts the user and interprets what was typed, using spaces as separators between executable words and numbers. All words in forth can affect the data stack. Values are popped from the stack, and results are pushed onto the stack. Numbers, integers, are simply pushed onto the stack on the assumption that they will be used by executable words. At the basic level, only words and integers are pushed onto the stack. In the case of this simple Python version, we simply push words as Python strings and Python integers onto the stack. For example, to add 1 and 2 together, we would Step 0, start with nothing. Step 1, push integer 1. Step 2, push integer 2. Step 3, pop 2 integers. Step 4, add the integers together and push the result. Simple.py. Simple.py creates several global variables. The forth stack, called s. A string of characters input from the user, called buff. An integer index into the string buff. It points to the next character in buff that hasn't been processed yet. The index is called buff_p. Simple.py just uses a Python dictionary to store functions associated with each word. The dictionary is called d. In this very simple version, there are only 8 built-in routines, each associated with a string key in the dictionary. The word by is associated with the routine xby. The word dot is associated with the routine xdot. Note that the key can be any legal string of characters. In this case, the dot character makes up the string key. The string word is associated with the routine xword, and so on. The code begins with a header dictionary call app. It gives the name of the project along with some details. As it's written, this is like a comment that can be accessed at runtime. Languages like Python, Lisp, Julia, and Elixir treat documentation as first-class language features, while most others rely on conventions and external documentation generators. First-class docstrings make it easier to experiment with code in an interactive manner. Compilers tend to delete such information, but keeping the information in memory makes it more convenient to experiment with designs. Of course, you could leave this information out to make the final executable even smaller, but size doesn't matter as much today as it did in the early days of computing. Forth uses a convention for commenting about the before and after contents of the stack. This Python version uses the same convention. The stack comment is an ASCII diagram of the stack. It consists of a parenthesized set of symbols separated by a double dash. The before stack is shown on the left of the double dash. The after stack is shown to the right of the double dash. The stack grows from left to right. The stack diagram for xadd shows that A and B are already on the stack. The xadd word consumes A and B by popping them off of the stack, then pushes their sum onto the stack. The operations of the built-ins xby, xdot, xdots, xadd, xswap, and xsub are very simple and are documented in the PDF. Xword is the input string parser. It slurps up characters until a separator character is encountered. The actual separator character is not hardwired into the parser, but is passed on the stack as a parameter to the xword subroutine. OK is the REPL, the read eval print loop. It repeatedly gets a line of input from the command line, then calls xword to chunk the line into words. Each word is sequentially provided to the xinterpret subroutine, which tries to look up the word in the dictionary and invokes the associated built-in subroutine. Or, if the word consists only of digits, it converts the word to an integer and pushes it onto the stack, or else it prints a very simple error message. This ordering is important. It means that we check to see if a word is defined as a function before trying to treat it as an integer. For example, the number 7 is just a word. It can be defined as a function and will be treated as such. Only if it is not defined as a function, we try to see if it is an integer. The Python mainline simply calls the OK function to run the REPL. Acknowledgements. Josh Fuller wrote the initial version of simple.py. This project is a spin-off from the Toronto Lisp users group, TorLisp. Repositories in Discord and TorLisp website. You can join the Discord if you want to ask questions, build your own in some other language, or just follow along.